So in this edition of Unfiltered, we're going to talk about robot C-arms, and we're going to demonstrate a working, no hassle, very functional C-arm that's actually done by 3dxray and it operates with their 3dxray system. So I've done videos before about how you can do cutoff in your image based on your generator height. So a lot of the robot C-arm configurations that you see, or robot and X-ray integrations you see, are going to mount the generator to the chassis. That's absolute crap. It doesn't work. It limits you to ground scans only, and it actually makes the lower edge cutoff actually massive. So if you see any vendor offering you a robot X-ray integration that the generator is mounted to the chassis, don't buy it. It's an absolute complete waste of your time. Okay, it's shit. They don't work. They're crap. They're a nightmare. They only do ground scans, and they do ground scans like shit. So don't buy them. What you want is a C-arm. Now, C-arms, there's a lot of different C-arms out there that are used, but you'll see a lot of failures in how they deploy them. And we'll talk about that with this system. So again, if you're X-raying something on the ground, your fucking panel's on the ground, your generator needs to be on the fucking ground, period. Or you're gonna have a lower edge cutoff. So if you're using a C-arm for a ground scan, it needs to have both the generator and the panel on the ground. Now this system does that, okay? Now, most of these systems, or some of them, you'll see where they've actually wired the X-ray system through the arm into the actual robot. And they're trying to integrate both the robot feed and the X-ray feed. That's a waste, okay? Because it's never going to be 100% correct where you have access to both levels of software. Typically, you'll have all the access to the robot software, but you'll have very limited access to your actual X-ray software. So like XTK and all that kind of stuff, you're never going to see that happen. It's going to be a hodgepodge sort of integration. And then what happens is you've actually wired the two in together, and you've turned your fucking robot, which is a $150,000 to $200,000 system, into a taxi for your X-ray system, which is a failure. Okay, the whatever C-arm they're using has to be able to just be set down and just set aside. All we're going to use that fucking C-arm for is the robot's going to transport it downrange so we can do an access to it remotely. We're going to take an X-ray, and then once we've done with all our X-ray shit, the robot has other things to do. We all know that. We don't buy robots to carry a fucking X-ray downrange and do X-ray. The X-ray's got recon responsibilities. It's got tons of other responsibilities. And when you look at a robot and X-ray integration, at any point you see where that integration has lost you capability from the system as it was by itself, it fucking sucks, okay? That's what you need to look at. What is my robot's missions? Okay, make a list of it. What is my X-ray missions? Make a list of it. None of this can be deviated from. Whatever capabilities both of these systems have, neither one of them need to be compromised when you have this integration. And that's the biggest thing you'll see in all these shit-ass integrations a lot of these vendors are doing, is you fucking lost all kinds of capabilities on either end, okay? So with this system, there is no loss of capability. All you're doing is carrying this downrange. It lets you do ground scans, and it lets you do above ground scans with the system. And the alignment is always going to be perfect. Now, the way their system works, they have a single pole that's made from carbon fiber. This carbon fiber pole is adjustable, so it works with both their LS3 panel and their large, gigantic LS1 panel. The way the system works, it simply plugs right directly into the generator, and they've already got the connectors. So the same connectors that you use for your tripods are the same connectors that you'll use for this system's C-arm connections. It's all the same, so you ain't having to change this shit out or that shit out. It's all the same shit across the board. All right, the next one is going to be going to your panel. It only has one pole for that, and the reason being is they engineered it to where it works on their LS3 panel, and it also works on their LS1 panel. And the alignment is already done based on how they've got it mounted. So you don't need to have different arms or adjustments or all that other kind of crazy crap. All right, and again, with the 3D X-ray system, it's actually designed with no wires. There's no wires to this system. So there's no Wi-Fi module attached to this. There's no fucking control box or a communication box that needs to be added to this. There is no add-on shit to it. You get a generator, you get a panel, and it all works by itself. So with this system, there's no additional shit I have to attach to it, okay? So next, depending on which panel you're going to use, this C-arm is adjustable. So the lowest distance is designed so you get complete X-ray beam coverage of your panel at the set distance, which on this one I think is like 90 centimeters, okay? The next one, if you go to the larger panel, you got to back your generator up because the cone's going to cover. And it's optimized to get, you're not losing a ton of energy because you got your generator too far away. So you guys that are shooting at these ridiculous distances, it's because you're losing a shit ton of energy when you do that. So there's an optimum distance between your generator and your panel that your generator should always be to get the most X-ray energy on the panel. And again, because we don't culminate the fucking beam, it's another issue. But then the system simply plugs in pretty simply. It has quick disconnects for both sides that plug in. And again, this system can be used for ground scans, and you can see because the generator's on the ground and the panel's on the ground, you're going to get no lower image cutoff at all. Very little. It's like 2.5 millimeter based on this system. And you can also do with this system above ground scans because the system can be lifted up in different angles. Now this depends on your robot's arm strength, but because of how light this is, you're looking at a system, this complete system right here with this panel is around 25, 26 pounds. I don't know if that is a kilogram, some American. This one, it shoots up just a little more. Believe it or not, this panel is like retarded light. Okay, you look at it, you think how big it is. This thing is ridiculously light. All right, so I think it only shoots it up to around 30 pounds with the larger panel. But I'll be honest with you, I like using the LS3 panel because it's smaller and it's able to move around a little bit easier. Okay, so again, once the system's all put together, it's just simply you grab it with the robot, and this is where people screw up. They'll take this and put it in front of the robot and try to drive. Okay, you're not getting to a door with this. It's going to be just a fucking nightmare. The way you should always do this is have this mounted over your robot and be carrying it like this, okay? So it should never be mounted or carried in front of the robot. It should be cut over top the chassis or mounted to the chassis as you drive to the point. And the arm can hold it in this configuration. You just need to figure out how to do it. This is just simple. This is how you tote a C-arm. You do not put a fucking C-arm in front of your robot and expect to get into a building. And this is why they're so limited and why people don't like them. So carry it in this configuration. I'm the robot. I'm carrying it like this. I go to my target. When I get to my target, I take it off, and then I deploy it wherever I need to deploy it. If it's a ground scan, you set it on the ground, you do a ground scan. If it's an above the ground scan, you lift it up, and then you can do the above ground scan at whatever angle you need to do. That's what makes this system so simple, is that that's how it works. And it's not tethered to the robot. It's never tethered to the robot. Robot can go down range with this, drop it off, go do a recon, figure out what it wants to do, then go back, grab this, go back, take an X-ray, finish all the X-ray stuff, set the shit down, and the robot can go back to doing what it's doing. You never lose capability with either system, all right? Never lose capability. Now, one of the things you will run into with a C-arm is you may not have optimized imaging where your panel and your generator are in correlation to your actual package. So this one has a built-in camera system that runs on 5.8 gigahertz. It can mount anywhere on this system. It's got a mounting system that's pretty simple to use. It just wraps and then clicks in. And again, this system will let you look at, and I typically mount it right here over my actual panel because the panel is what's going to be getting closest to the actual package. So it lets you see exactly where it is from a downward view, and the system comes with a little mini 7.4-inch screen. I think 3dxray is looking at actually integrating this into their software, but right now they just use this system, and it's very simple to use. It lets you see from a downward view exactly what your panel is located at. So this is perfect. So this is a very simple system to use. It's inexpensive. It's not crazy expensive. And it works with the entire 3dxray Systems product line. And you can buy the LSC system, which has both the large panel and the small panel. And it all integrates in together with all of them. So it's pretty simple to use. You just got to know what the fuck you're doing when you're integrating in a robot and an X-ray system together. If it's not done correctly, you've got a bag of shit. If it's done correctly, you end up with something that's good like this, okay? Right way and a wrong way, just use your head.